Okay, so today we're going to be learning about double angle formulas. What they are is basically they're the same thing as compound angle formulas. So if you were to do sine x plus y, which is equal to sine x cos y plus cos x sine y, it'd be basically the same thing as this, except that instead of doing x plus y, it would be two x's. So it would be sine x plus x if we want to do a sine double angle formula, which would be equals to sine x cos x plus cos x sine x, which was then equal to sine x cos x. Compound angle formulas can be used to get exact values of certain values, as shown up here with cos pi over 4 plus pi over 6. The equation up here is shown, and you can get the exact value of it. But with double angle formulas, they have other uses because they have their own different formulas because of having two x's instead of x plus y. So these are all of the double angle formulas. There's sine 2x, which is equals to 2 sine x cos x. There's cos 2x, which is equal to cos x minus sine x, which is cos 2x minus sine 2x. And there's tan 2x, which is tan x plus tan x over 1 minus tan x, which is 2 tan x over 1 minus tan 2x. But cos 2x actually has two other equations as well, because we can use the trig identities formulas to get cos 2x, to get the two other cos 2x equations. So there's, because of the sine 2x plus cos 2x equals 1 formula, we can get sine 2x is equal to 1 minus cos 2x, or we can get cos 2x is equal to 1 minus sine 2x. So if we were to use this in the cos 2x formula, which is cos 2x minus sine 2x, we can substitute either the cos 2x or the sine 2x to get either all cos or either all sine. So this can either be all sine, which is 1 minus sine 2x minus sine 2x, which is then equal to 1 minus 2 sine 2x. Or we can get, if we go over here, we can get all cos, so this would be cos 2x minus 1 minus cos 2x, which is then equal to cos 2x minus 1 plus cos 2x, which is then equal to 2 cos 2x minus 1. So these are all of the double angle formulas. There's 5 in total, and these formulas are basically the same thing as the compound angle forms, except that instead of x plus y, like sine x plus y, it would be sine x plus x, which is then what happens to all 5 of these, and this is how you get the double angle formulas. So what these formulas can be used for is application questions. For example, something like this: if sine pi of is equal to -4 over 5 minutes in quadrant 3, we can find an exact value for sine nu theta, cos theta, and tan nu theta. So what we would do for this question is we would start by drawing a graph with the CAS rule, and with this is quadrant 1, 2, 3, 4. And then we know that it's in quadrant 3, so we're going to draw in quadrant 3 with the little triangle. And then we know that it's -4 over 5. Sine is equal to opposite over hypotenuse, so when the opposite is -4 and the hypotenuse is 5. The reason the opposite is -4 and is negative and the hypotenuse isn't negative is because a hypotenuse cannot be negative. So what we can do with this is we can find the length of the last remaining side. We'll name it b for now, by using the a squared plus b squared equals c squared formula. So it would be -4 squared plus b squared is equal to 5 squared. So then it would be 16 plus b squared is equal to 25. And then if we were to move the 16 over, it would be b squared is equal to 9. And if we take the root of both sides, b is equal to plus minus 3. But in this case, we're going to use -3 because it's in the third quadrant and it's going backwards, so it's negative. Now that we know all three sides of the triangle, we can figure out the values of sine x, or sine theta, cos theta, and tan theta. So in this case, sine theta would still equal -4/5, which is what we were given at the beginning. Cos theta would be -3/5, because it's the adjacent over hypotenuse, and then tan theta is equal to the opposite over adjacent, which is -4/-3. Now that we know the values of each three angles, or each three sides when they're at a theta, we can sub these into the double angle formulas to find the exact value of each double angle formula. So for sine 2 theta, it's equal to 2 sine theta cos theta. So we can sub in these sine theta and cos theta here, which is then equal to -4/5 and -3/5, which is then 12/25, which is then equal to 24/25. And we can do this for cos theta and tan theta as well. So for cos 2 theta, it's equal to cos 2 theta minus sine 2 theta. So we would just sum in the values again. So then it's just -3/5 squared minus -4/5 squared, which is then equal to 9/25 minus 16/25, which is then equal to -7/25. And if you want to get the exact value for tan 2 theta, you would just do the same thing as done here, and you would sum in the values required here in the double formula for tan 2 theta, and that's how you would get the exact values of sine 2 theta, cos theta, and tan 2 theta using the previous values here.